In last few lectures of material testing and evaluation, we have discussed about various materials like cement, sand, bricks, aggregates, etc. Now, in this lecture, we are going to discuss about the most commonly used material for RCC structure, that is steel. For better quality of construction, we have to study about properties of each and every material. Since steel is used for taking shear stresses and shear loads, it is necessary to study properties of steel in detail. Myself, R.V. Zugdar, Assistant Professor in Civil Engineering Department, Sharad Institute of Technology, College of Engineering. Since steel is the most commonly used material for RCC as a composite for giving properties of tensile stresses, the mechanical properties of steel are very important for studying purpose. The properties of material that determine its behavior under applied force are known as mechanical properties. They are usually related to the elastic and plastic behavior of a material. These properties are expressed as function of stresses and strains developed in it. For stress and strain development, the loading is given on the metal in the form of tensile loads or in the form of shear loads. A sound knowledge of mechanical properties of materials provides the basis of predicting behavior of materials under different load conditions and designing the components out of them. Stress and strain. The behavior of metal under loading always creates stress and strain in it. Therefore, the study of stresses and strains produced in metal after loading is most important. Experience shows that any material subjected to a load may either deform, yield, or break depending upon the magnitude of load, nature of the material, cross sectional dimensions. The sum to- total of all the elementary interatomic forces or internal resistances which the material is called upon to exert to counteract the applied load is called as stress. Means stress is nothing but it is opposite reaction to overcome the load or counteract the applied loads. Mathematically, the stress is expressed as force divided by cross sectional area. In this diagram, stress is shown how pulling stress or pulling loads acting on the cross sectional area of the metal and how the stress is calculated from particular cross sectional dimension and force applied on it. If a metal has cross sectional area of A and the force is applied on neutral axis of it as P or F, then the stress is calculated by simple formula force upon cross sectional area of metal. What is strain? Strain is the dimensional response given by the material against mechanical loading deformation produced per unit length. Mathematically, strain is change in dimension divided by original dimension. Either it may be length, width, or diameter. This diagram shows the dimension, that is length of metal initially and length after loading or pulling of metal. In initial stages, if there is no load, the length of metal is L, and after pulling by applying some load on that metal or neutral axis, the metal elongates by dimension of A, and in this case the strain can be calculated by the formula L plus A divided by L, that is change in dimension per original dimensions. The next property of metal is strength. The strength of material is its capacity to withstand destruction under the action of extra external loads. It determines the ability of material to withstand stress without failure. The maximum stress that any material will withstand before destruction is called as ultimate strength. Means at load, when material or metal start breaking or it breaks, then that load is called as ultimate load, and that strength is called as ultimate strength. The next property of metal is or steel is elasticity, which is most important property for using of metal in RCC structures. The property of material by virtue of which deformation caused by applied load disappears upon removal of load. Elasticity of a material is the power of coming back to its original position after deformation when the stress or load is removed. Means elastic limit or elasticity is that property of body or metal when it regains its original size and shape after removal of loads. But after elastic limit, if load is applied, the body will not regain its original size and shape. That is elastic limit of the body, after which the body will not regain its original size and shape, and it will become plastic. This diagram shows the elastic limits of the body. In first diagram, the body is in elastic limit, and after application of force F, there are change in dimension of the body or change in length, and after removal of the load, the body regains its original dimension as it is. This is up to certain loading conditions, but after increasing load, the body will not regain its original dimensions and starts elongating even after removal of load. That is called as elastic limits. The graph shows the linear elasticity or linear elastic limit of body and non-linear elastic properties of body. The next property is plasticity. The plasticity of material is its ability to undergo some degree of permanent deformation without rupture or failure. Plastic deformation will take only after the elastic limit exceeds. It increases with increase in temperature. Means in certain cases the body undergoes the permanent deformation without any failure in it. That particular point is called as plastic limit of the body. The figure shows the plastic behavior of body in which even after applying force the body elongates and becomes plastic state and it will not undergo any type of rupture or failure. The next property of steel or metal is stiffness. The resistance of material to elastic deformation or deflection is called as stiffness or rigidity. A material which suffers slight deformation under load has a high degree of stiffness or rigidity. For example, steel beam is more stiffer or more rigid than aluminum beam. The next property of steel or metal is creep. The slow and progressive deformation of material with time at constant stress is called as creep. Depending on temperature stresses even below the elastic limit can cause some permanent deformation. It is most generally defined as time dependent strain occurring under stress. The next important property is ductility. Ductility is nothing but the property of material which enables it to draw out into thin wires. For example, mild steel is a ductile material, means after pulling or applying tensile loads, that particular metal or wire or bar elongates up to certain limit and it forms thin wire than previous diameter. The percentage elongation and the reduction in area in tension is often used as empirical measures of ductility. The following figure shows the ductile nature of the body after tensile loads or pulling loads on the metal. It will form the cup and cone structure at certain length of the metal and it elongates up to certain limit and it forms the thin wire like structure. The tungsten cable is high elongation index. Malleability. Malleability of material is its ability to flatten into thin sheets without cracking by hot or cold working. For example, lead can be readily rolled and hammered into thin sheets but can be drawn into iron. Means after application of certain hammering loads or impact loads, the metals or steel undergoes the flattening of its body. That property is called as malleability. The malleability property of gold, silver, and platinum is more as compared to any other metal. Therefore, these metals are used for ornamental purposes. As compared to these materials, steel has less malleability and ductility, and therefore it is used positively in RCC structure. The next property is resilience. It is the capacity of material to absorb energy elastically. The maximum energy which can be stored in the body up to elastic limit is called as proof resilience, and the proof resilience per unit volume is called as modulus of resilience. The quantity gives capacity of material to bear shocks and vibrations. The following diagram shows the malleability property of the metal. It absorbs the shock up to certain limit and elastic limit up to certain limit is called as proof resilience. The next property is hardness. Hardness is the fundamental property which is closely related to strength. Hardness is usually defined in terms of the ability of material to resist to scratching, abrasion, cutting, indentation, indentation or penetration. Method used for determining hardness is Brinell, Rockwell and Vickers. The next property of metal is brittleness. It is the property of breaking without much permanent distortion. Non-ductile material is considered to be brittle material, for example, glass, cast iron, etc. But steel or metal is a material which is ductile material and hence it is used in RCC. Now, in this lecture, we have studied about various properties of steel or metal. For checking that properties, the various assemblies or various tests are carried out. The most commonly used test for testing steel is use of UTM, that is universal testing machine, by which we can find out the ductility or property of taking tensile stresses after loading.